there's a lot of companies that still today have individuals in place that rather than teaching someone how to fish, they'll just give them a fish. And in my opinion, that's the wrong approach. Board design isn't just, let's just draft something on paper, and it's more than that. It's true printed circuit engineering, at its core.
Hello, everyone, and thank you for joining the On Track podcast. I am Zach Peterson. I'm your guest host for the next couple weeks. Judy Warner is out of the office planning Altium Live 2022. But she will be back shortly and resume her position as the regular host of the On Track podcast. Today, I am here with Steven Chavez, chairman of PCEA, and also he works at a major aerospace OEM. And he's got tons of knowledge that he loves to share, and that's kind of the mission of the PCEA as well, is to aid that knowledge transfer to new designers.
Welcome to Altium's On Track podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media.
Steven, thank you so much for being here on the On Track podcast.
It's my pleasure and an honor to be here. This is a great platform of continued development and education for designers going forward. So this is great. Great job you guys are doing here.
Yes, thank you. And you've been on the podcast before. I'm not sure the exact date, but we'll link to that in the show notes.
Sure.
Since that time, working in the electronics industry, things change so quickly. And one thing that seems to have not changed, and it's an area where PCEA is active, is knowledge transfer. And that's kind of a theme that we've been talking about with multiple guests, I should say, on the podcast. I know that you have a really broad depth of experience in the industry, so maybe you can tell our listeners a little bit about your experience and how you came to be affiliated with PCEA.
Sure. So I would tell you one of the fundamental things that is I'm very passionate about is continuous development. You have to constantly be evolving in today's industry because it moves so quickly and things evolve the way they do that. Just attending a trade show or watching a video or a podcast one time and that's it, it's not going to work. You've got to be on top of things as things change. And what maybe have been industry best practices yesterday may not be going forward the best practice because as things evolve. And for me, getting out in the industry, attending the conferences, attending webinars, attending different shows or watching different podcasts, the content that's out there is amazing today versus years of past. And that's a huge evolution in our industry and how designing the printed circuit boards are evolving and has evolved. And it's a credit to the industry as well as to today's designers, whether they be EEs or actual PCB designers, whoever's designing the boards. As today, it's a collaborative effort. It's not just a one-man show anymore. Years past. So
yeah, I totally agree with you. I was actually talking to someone at a commercial space company yesterday and last week, and I was kind of asking them, how do you guys operate? And he said it's almost like it's constant organized chaos. Everybody's working with each other, and yes, everybody's helping each other put out each other's fires. And the one takeaway I got from that was that, what they're designing is incredibly complex. And I mean, you're in the aerospace industry, you obviously understand all of this. And with that complexity comes the need for, cross collaboration, the type of stuff that's enabled by like Altium 365. But, that cross collaboration, how has that changed over the past, however many years you've been in the industry? I mean, you're more experienced than I am, so I like to get that perspective.
Yeah, so I would tell you, so in today, we talk about the digital thread or model-based design. It starts from the very beginning. And today, you no longer have one or two individuals that are carrying the load for the entire company or team. today you have a team of people doing it, and with today's tool sets that are highly integrated, in my case, the tool that I use, the evolution of that tool and how it's evolved with its digital thread from, the start of it through design, through fabrication, through assembly, and then, you talk about, configuration management and how it's handled in its product life management of the whole design itself. Today's designs and today's tools are much more superior than of tools in the past. And taking advantage of that horsepower that's there, in order to be truly successful, you've got to be taking advantage of whatever tool you're using. Utilize that horsepower that's available to you rather than doing things in a manual approach. Don't get me wrong, there's a lot of people that have been very successful and continue to be successful, but the companies that are truly making industry strides and really successful, they are utilizing the horsepower in their respective ecosystem and how they're designing boards. And as I see, when I first started about over 30 years ago to where I am today, that's one thing I would tell you where I have changed is I now trust my tool. And that doesn't mean I just push the button and then let it fly. I control in the chaos, as you described. I control that chaos. And a lot of it, it stems from my military background in the Marine Corps and being able to handle chaos. And really, for me, in the, when you think of the design cycle itself, how one reacts under battle conditions or in the true design when you're under the gun, under the wire, how you handle that, everyone reacts differently. And I've been very successful with the tools that I use and how I wield it. And I think, when I think of the designers today, those designers that are really successful really have mastered their craft as well as their tool. And in design, you've got to do both. You can't just master the tool and not master how to design boards. You've got to know how to design boards and then how to do it within your ecosystem or the tool that you're using.
Yeah, I totally agree with you. I mean, I think part of the issue with knowledge transfer and bringing up that next generation of designers, obviously tool training is important, like you mentioned, and unlocking all of the little secrets within whatever CAD tool it is you're using. However, board design and some of the contemporary issues in board design, I think are things that used to be the exception and have now become the norm. And so as that shift has been made, stuff like high speed, stuff like understanding things that happen at high frequency, as that becomes the norm, a lot of designers kind of get left in the past. And so they need to have those resources to be able to come up to speed and understand that, this stuff is regular. It's not an exception design. It's not
you're
super
absolutely
advanced.
Right. And that's, my involvement early on in my early stage in my career of getting involved with IPC. That was the kickstart. If we look at how my career has evolved, and the way I describe my career is exponentially. I can pinpoint a time in my career when I effectively started to use one specific tool along with getting involved with IPC. It's one thing to use the specs, it's another thing is to get involved with the committees, and the way I describe it is get off the bleachers and get into the game. And then I started to really find other individuals that had the same knack, if you want to describe it as the same knack, and you start cross collaborating, and that is what makes a difference. And as I evolved, and now that I'm chairman of PCA, my passion is giving back to the industry and what I want to do of collaborate, educate, and inspire, which is at the core of our mission statement, is just that. I remember Steph when he was just starting out. Now, how can I ease Steph and help him back then, or someone like him that didn't know where to go, couldn't find a university that teaches this stuff, and rather than learning the school of hard knocks and drudging through 5 or 10 years of a brutal, getting off the ground in your career, get into a collective hub where you can have individuals like myself, Mike Creedon, Rick Hartley, Gary Ferrari, Susie Webb, and such, and as yourself, out there talking and sharing knowledge and willing to share. And that's the difference. And one thing I noticed from when I started out, people weren't so eager to share knowledge because it was all about keeping their job. Whereas now it's more open. People are willing to share and willing to help each other. And that's the difference that I see that has evolved with the designers today.
That's really interesting. It almost seems like some of that design knowledge may have been viewed as like a trade secret, proprietary information. Is that really the mentality that was?
It was early on. That it was the mentality of, you know what, I'm not going to tell you how I did it. You just give it to me and I'll do it. And there's a lot of companies that still today have individuals in place that rather than teaching someone how to fish, they'll just give them a fish. And in my opinion, that's the wrong approach. And when we think of mentorship, which is, what we do here at PCA is we want to mentor the younger generation, or what we call the next generation engineers, to learn how to fish and to do better and take it to the next level, because the industry is evolving. Like we talked about, our tools are evolving and it's getting more and more of a challenge as things are getting smaller, they're getting condensed. There's more things that we got to rely on, and we talk about, reliability, talk about producibility. There's so many different aspects. As speeds increase, thermal becomes an issue, and board design isn't just, let's just draft something on paper, and it's more than that. It's true printed circuit engineering, at its core.
Well, that's why I love the PCE and PCEA, like you say, it is printed circuit engineering, because I think it does take an engineering mindset, not just in terms of how do I get to a good design, but what are the trade-offs? And I know that's something I talk a lot about in my own research in terms of optimization. But Rick Hartley did a great presentation on PCB design optimization and talking about that type of stuff. So I totally get what you're saying when you say printed circuit engineering, and definitely agree with you. But there's one thing that I think is interesting in terms of how the industry has progressed, and some newer designers are kind of getting left behind, which I think is something where you're really knowledgeable, which is dealing with your manufacturer, how to work with your manufacturer. It's at least for me, being a younger person in this industry, I try and learn as much as I can about manufacturing, and it's an area where I'm not a manufacturer. I'm not at expert level yet, but I really want to get there, because we do have to design boards for manufacturing, and I'm sure that's even more true in the aerospace industry, where things have to have high reliability. They have to.
It's much more.
Yeah.
I mean, when we think of aerospace, in general, let's just think about commercial side of it. The whole essence of aerospace is moving people safely in the air. And you have to always have that mindset in place, because safety is paramount, especially when it comes to, people flying. And so reliability and producibility is key. And when you're designing circuit boards, you've got to always keep that in mind of the decisions you make in your current state in your design, whether you're designing the schematics or you're designing the layout. You got to understand the impact you make downstream. And good designers know this, and they're aware of this. For example, if you're picking a connector with a certain type pin pitch, or you're choosing a part that is like a micro BGA, you are automatically pinning yourself into a category of complexity that is at a higher level. Do you understand what you're already boxing yourself in a corner into? And you'd be surprised how many people don't realize that. And they could make it more cost effective. They don't have to make it that small or choose that particular part, and the downstream effect it has in assembly when they're doing this. And this is where, when you think of, what I refer to as a designer's triangle, where you got, your layout solvability, then you have your performance, whether it's SI, PI, and thermal, and then you have your DFM. You've got to make sure that you're covering all three bases to be successful. So your first design you design, when you pull the trigger and fab it, you're successful. You're not going to have any surprises downstream. And when you talked about producibility, you want to make sure that you design a board that, whether it's the first board or the 1000th board, it functions the same regardless, and it can be built the same. Whereas, in my early stages of my career, one of my early mentors said, any circuit board can be built one time at a serious premium cost, but it can be built somewhere in the world. Somebody can build it, but that's not what your goal is as a designer. Your goal is to design a board that can be fabricated anywhere, any place, and any time, whether it's fabricated or assembled. So that's always been my mindset, is how to design a board so that way it always meets the sweet spot within that fabricator and assembly. And so it's imperative that when you think about the design itself or the design cycle, that you all have the appropriate stakeholders in the beginning of that process. That includes your fabricator, that includes your assembler. And when you think of the education of your design team, your young EEs, your young PCB designers, and even mechanical, they need to visit a fab shop, they need to visit an assembly shop, so they understand all the intricate details that go into designing that board, so they know that when they make the requirements in their documents, whether to fab it or assemble it, they understand what they're saying. So that way it's a smooth transition from within the design, then to fabrication, then to assembly, and then eventually into test. And so it's a truly integrated system. And when you think of the digital thread within our tools and how we use it, it's amazing from where the manual approach of what we did in years past.
Yeah, that's really interesting. You bring up, talking to your fabricator and possibly even going and visiting your fabricator if you can. I totally agree with you. I think, maybe you're in the US, your fabricator's in Europe, maybe that's not feasible, but
it doesn't even have to be your current fabricator. Just visit a fabricator. They will trip over themselves to help show you and enlighten you in their process to make it easier. Believe me.
Well, yeah, it makes sense. They're going to want they're hoping to get your business at some point.
Oh, sure.
Yeah, if
you're absolutely right. And so it's the majority of fabricators are always willing to showcase the floor because, in the end, let's be real. Everyone's, got to make a living. And of course, they're looking to hopefully win your business. And so a good supplier isn't in it for a 1 or 2 PO that is a $10,000 or even a $30,000 PO. They're after the 10-year, 20-year relationship. And a good supplier understands that. So they're all in. They'll be all in. Even though they know that this prototype that they may be working with you, it may not go to them. They may go to a smaller firm or a smaller prototype shop. And they're okay with that because they're in it for the long haul of that relationship. So when you go to manufacturing or when you go into true production, they're the house that you choose. And so good companies, they understand that. And when it comes to training your people and keeping them educated, it's advisable to at least your local fab shops. If you can get out there, go out there and give a tour and take your younglings or your younglings, take your younger generation engineers and let them see and understand, what it takes to fabricate and assemble a printed circuit board.
Yeah, I agree. When I was down at PCB West just a couple months ago, we got to go tour a factory, and it's really eye-opening. It's not my first factory tour, but seeing that particular facility was really eye-opening, and how they have everything organized and what their capabilities are, what the machines they use actually do. And it just kind of gets your wheels turning as far as, how can I design this better so that it's streamlined through their process? And I guess it's not just about cost, but it's also about reliability and producibility, like you say.
Correct. And having them involved early on will increase your percentage for success when you go to fabricate that board. That's for sure.
Yeah. Totally agree. Everyone who has ever watched any of my videos knows it's the catchphrase is I kind of lifted it from Mike Creedon. So kudos to Mike Creedon for this. Don't forget to call your fabricator. You were there.
No, you're absolutely right. Yep, Mike is amazing. He's like a brother to me, big brother, definitely a mentor of mine. I love Mike. He's amazing. He's good for the industry, and we need him. We need gurus like him spreading that knowledge, and he's doing a hell of a job.
Yeah, and there's actually another On Track podcast with Mike Creedon, so I'm going to link to that in the show notes because that is also an eye-opening discussion and specifically talking about PCEA. So, back on the topic of manufacturing, if you're like a large company, you're probably working with 1 or 2 suppliers. Maybe you've got your smaller prototype shop. Maybe you've got your large full-scale producer.
Sure.
But if you're a service bureau, you may not have that luxury. Maybe you're like, what my company is, where we've got like a handful of business cards that we kind of farm out or, shove out in front of customers when they want to produce something and say, these guys can do this, these guys can do this. you want to produce at class 3, I recommend these guys. And, you kind of give them the menu of options. I mean, when you're in that position versus just working with one supplier, it seems that if you're working with the one supplier, you can just call them up and say, hey, is this going to work? And they're always going to be able to give you the yes or no. Is that the correct view?
In general, when it comes to being like a little firm or a service bureau, that is true in a sense where you're not making the decision, the customer is making the decision on which shop to go to. So you are basically coming in as a hired gun to design whatever you need to design for them. And it's usually, at the end of the year is the worst. Like this time of year is always the peak of when they need support, because they're trying to get it in. So that way it's all about timing. So that way when they come back from the new year, they've got a board in house ready to be tested and demos, whatever case may be. But you're right. When it comes to service bureaus, they don't really have dedicated unless they are a customer is coming to them and says, here's a widget. I want you to design this widget. And then you're going to do a full turnkey. Then you're going to go to your go-to houses that you go to. But in general, you're designing with the concept of, I'm going to use whatever my customer is telling me to go to. So you've got to then sync up with them and go from there. But at its basis of design, you're using industry best practices. So it shouldn't really matter where you go. When you're designing a board, you should not tailor your designs to one specific supplier or another. You want to make it general so you can go anywhere. So when you're designing your boards, whether it's extremely complex or a very simplistic design, it's at its base, it can go anywhere. You can send it to any company. So good engineers understand this and they will apply this when they're designing their boards.
Yeah, I totally agree with you, especially with designing anywhere. It seems that sometimes one CM or one fab house will get chosen. They may not hit the quality standard that the client wants, and so
sure,
round 2 we go to someone else, and you got to make sure that you can produce at both places.
You're absolutely right, and a lot of times you have in several when I used to work for a design firm, a lot of the aerospace companies we tapped into, they had tier levels: tier 1, tier 2, tier 3, and your tier 1s are your big companies. And I won't mention their names, but they're very large companies that most of these aerospace companies tie into. And you're right, most of the times they're working directly with them. But when you get the mid-sized companies or even the small companies, that's not to say these small fab shops and small assembly shops, they can't bring it, because some of them are just as amazing, if not even more so, because they're not as big and they can focus truly on just their core of what they're really good at. But it's on you as the engineers to make sure that you're filtering your suppliers and that you're on top of them to make sure that they meet the standard of the qualities that you're after. And a good shop will work with you to make sure that they are meeting your requirements in that regard.
Yeah. The what I'm hearing here is high volume needs to be less complex if possible, because you could take it to multiple different suppliers if needed, and then you can ensure that you're actually going to have something that is reliable and hits your yield target and is producible and all of this. Whereas, you brought up like a smaller shop that might be more focused. Maybe they're more focused on high density. Maybe they're more focused on, unique material systems or whatever it may be, and they're going to be able to focus on you and hit your requirements. It's interesting because I think when a lot of new designers enter this sphere, they don't really make the distinction between those different types of manufacturers and what it means to manufacture at high volume versus designing the manufacturer for just quantity 10 or quantity 1.
Yeah, and a lot of people don't even realize in some of these large tier 1 level companies, it's like an umbrella because of all the acquisitions and mergers that happen within the industry today. You may send it to the tier 1 shop. They're going to farm it out to who they're going to level load. And they're going to say, okay, this is a class 3 design. It's a multi-layer. It's got sequential lamination. It's HDI. We're going to send it to this shop. But the next go around, that shop may not be able to meet their requirements as in the delivery time. So then they're giving the customer, like let's say an aerospace company may say, hey, I need it now. I don't need it 6 or 8 weeks from now. I need it sooner. So therefore, I want to send it somewhere else. Well, guess what? That other house may not be as qualified. And it's happened in my career where designs had to be dumbed down in order to send it to somewhere else. And it's a wrong approach to dumb down a design. But, when supply chain starts moving things around and trying to cut costs and figure out, I can get it cheaper. Well, there's a reason why that place is available, and there's a reason why they're cheaper, because they don't have the complexity. Everyone else is going to, supplier A, because supplier A can bring it. They're a high quality house, and this is why they're backed up. Everyone wants to go to them.
Yeah, you get what you pay for.
You get what you pay for, and so it's a behoove you to know your suppliers and have a relationship with them, and make sure you continue that developmental relationship going forward all the time. Whether you use them once or you use them continuously, I always say you never burn a bridge. You always want to keep that dialogue open and moving forward.
Yeah, one thing I see often from newer designers is this idea of, I just want to produce it as cheap as possible. And it's kind of a race to zero on cost. And it's not just like, how do I design this so that it's as cheap as possible for components, but also for fab and then for assembly. And then I think people are too willing to sacrifice quality problems, even if it is just a prototype run. And it even gets to the point where I think it compromises performance as well. It's not just manufacturability, but people start eliminating planes. They start implementing bad routing and grounding practices, and they do all the stuff that's going to cause them to fail EMI and fail SI, fail PI, whatever it may be.
No, you're absolutely right. So the way I think of this is it's like mathematics. When you get into high complex mathematics, a lot of engineering students or a lot of people make mistakes at the rudimentary algebraic steps. And so I think of design the same way. A lot of mistakes are made for simple, concept like, are you routing a trace over its appropriate routing plane? Did you route it over a gap between planes or in a moat? I mean, when you transitioned from one layer to another, did you use a transition via? Did you do this? Are you aware that you're running, several gigahertz? What did you do in your analysis? If you're using IBIS models, is the IBIS model correct? Where did you get the information from? Did you do any EMC checks and you went into EMI testing? What did you do up front to prevent that? Because you don't want to design, or you don't want to check for quality. You want to design quality into it. And that's always, a concept that I say is you design for quality, you don't check for quality. And you got to do all that legwork up front. And believe me, it'll pay off. And it always seems like in the beginning of the project cycle, it's always slow at taking off. And, those companies that are doing their due diligence and doing their simulations and doing all their checks up front, it pays off in the long run, because when they design their board, they're going to be successful in the lab. So that way it's not, a shot in the dark, and, the magic really gets to happen there in the lab.
Yeah. It sounds to me like, I'm not the only one that says this. We just recently had a talk with Eric Bogatin, who said something similar, which
he's
is
amazing.
Yeah. He's great. What he said was that people have bad yardsticks. Like, what is your yardstick for success? And it sounds like the companies that are highly scalable, you said, maybe it takes longer to start a project, but they're doing that due diligence up front to really define what success is. And so maybe it's not, ultra low noise, but maybe it is compliance to a specific standard. Maybe it is producible with X number of fabricators. I don't know what all those possible variations on yardsticks are, but, I kind of wonder, how do you get there and how do you balance that? Is it just, especially with something like high reliability, like aerospace, is it just looking at industry standards? Is it based on testing? Is it based on simulation? How do you balance all of that?
I would say it's a collaboration. It's not just one area or the other. It's a collective influence of all different aspects. When you think of design, as a fully embedded approach, or when you think of the ecosystem of design, every link in that chain is equally important in order for that chain to be strong. So when you think of design, you have your different roles that are played. You got your AAs, your EMC engineers, mechanical, software, firmware. There's so many team members that contribute to the success of your design. All that has to be taken, accounted for, and each person or each team member plays an important role in order for the entire project to be successful. So, nowadays the budgets are smaller, the time to market is faster, the window of opportunity is less. So being able to do things faster is the key. And companies that get it, they're applying this approach in how they utilize their team members. And one of the things when I think of early in my career is, when is enough that you can pull the trigger and move on? Because in the end, getting the board in the lab and getting it in the EE's hands for testing is, I always say that's where the true magic happens. You can do all the simulations, but that's theoretical. It's not until you actually get it in the lab till you really find out, did it produce, or is the expectations of what I thought it was going to do, did it meet its requirements? If you do your due diligence up front, the percentages are higher and you're more likely to hit, within that sweet spot of where you need to be. Whereas if you don't, you're guessing and you're hoping it works, and that's a waste of money, waste of time, and you're more likely to fail. Believe me, I've been there. Lessons learned in my career, early on in my career. The teams that I've been on, I just started off, and you got to start somewhere, and we all make the mistakes.
Yeah.
Lord knows I've made my share.
Yeah. I think sometimes we don't want to admit when we make those mistakes, especially on a critical run. You mentioned the real magic is in the lab, and I totally agree with you. I mean, so when I was, teaching at a university, working at the graduate level, one thing I noticed was that the test and measurement, really, theory, whether it's at the board level or any other level, sometimes was lacking. And especially once you get into a graduate program, it's like you go into a lab, and if there isn't someone there to really walk you through an instrument, it's like, hey, here's the manual, good luck.
Yeah.
What kinds of, I'm wondering if that, really contributes to.
No, I would tell you, you're right. I mean, when I started off in my career, I was a technician, an engineering technician. I wasn't a designer. I got the Marine Corps in avionics. That's what I did when I was in the Marine Corps. So when I got out, I thought I'd, follow my career as I was chasing my EE degree. And I was a technician. So learning how to use scopes and measuring equipment and test equipment, there was really nobody there to teach you. You gotta, like you just said, you pick up the manual and you start fumbling. How do you do this? And hopefully you have some senior people that are in the lab with you that are help guiding you. Because if not, you're having to learn the hard way. And it's not like today, where today you have application engineers that are willing to come on site and walk you through on how to use their equipment. Then or there's YouTube videos now. Oh my God, YouTube you can learn anything on YouTube. And it's amazing, of what's available today to learn. But at the same time, there's what I call a lot of noise out there in the industry, and you got to be careful of what you pick up, because they may not be best practice, or it may be touted as best practice, but it's not really best practice. So you got to be careful of what is out there just as much as the good content that's out there.
Yeah, I totally agree. And I think one of the problems is that sometimes you see advice that was best practice in the past, but now all of that context has been lost. It's like a big, long historical game of telephone where it worked fine in system A, and people try and extend it into systems B, C, D, E, and F, and 30 years later, it actually stops working. So it's almost like the guideline and the justification is taken out of context, and then that causes design practices to be misapplied. For me, in my experience, the biggest one is split planes. Yeah, I'm wondering if you've seen any particular instances yourself of where that happens.
Well, what I have just seen is, as I evolved in my career, a lot of good engineers that I have had the pleasure of working with, or the honor of working with, I've been very fortunate. They've guided me in the right path. But there were a lot of times where the information that was handed to me, early on, it wasn't, I don't want to say it wasn't industry best practices, but it's what they used to be successful. But they were successful, but they were on the low end of the rail. So yeah, they were successful, but they were on the low end of just meeting their requirements, and any deviation, and it's like below and failing, barely working, it's like skipping along. And that was my mindset early on. But as I said, once I got involved with IPC and I started using Mentor Graphics, my career just took off. And it's just mentorship is a big thing. This is why in PCEA, it's really big on collaborating and sharing. And we're tool independent, so it doesn't make a difference what tool you use, because in the end, designing a circuit board is the key to designing, not the tool. It's the designer and the engineer that make the difference. And do you understand what you're doing? And then mastering whatever tool you choose to use, or whatever you are, your ecosystem, because in the end, you're going to use whatever tool, whatever company hires you. And that's the tool you need to master and use it to your advantage. And it's behoove you to do that. And I always preach that, when I'm teaching certification classes, is to master the tool that you're using. It doesn't matter which tool, to take advantage of that horsepower, and to step out of your box of doing everything manually and look for ways to see how you can automate things to be faster and better.
Yeah, I mean, there's definitely process to be followed, and I know that
sure.
Yeah, that helps streamline everything, but it's almost like the tools are just productivity machines. It's not necessarily about like you're only going to be able to design this thing in this tool, so you need to go buy this tool. It's more up your skills. Right. Your skills are what's going to get the design, and not necessarily the tool.
You're absolutely right. And the tools are just a means to a result, and it's up to you on how you apply it to be successful. I mean, no matter which tool you're using. And today's tools are not like years past. Today's tools have a lot of automation built into it. I know there's always a lot of chatter whether I'm going to, let's say, for example, auto route. I'm going to auto route, or I'm not going to auto route. Oh, I'll never auto route. I got to say, early on in my career, I would tell you I'll never auto route a board. I would never think of it. As I evolved, and especially when I started working for a service bureau, I would tell you there are service bureaus that are high end. I tell you, if you're not utilizing that auto router, you're not going to be successful with them. And you've got to be faster and better, because that's what they're paying for. That's what they're paying those top premium dollars. They want you to be better and faster and get that design done. And then you get into like design reuse and the IP reuse and how you can do it. There's certain companies that do this and that really do it very well. And if you can take advantage of design reuse, I know that one of my recent projects, we killed it on design reuse, and it's amazing how fast you can design a board when you utilize the horsepower in the tool or in the whole ecosystem. When you think of your MCAD ECAD collaboration, you think about into your PLM system. And how you can tie into your simulation, how you can tie into your DFM checks within the full digital thread. By the time you're finished, there's no guesswork. You already know what you're going to produce, and you're just verifying that your design quality is there.
Yeah, I totally agree with you. In fact, that's kind of Altium's new push, is that collaboration and cross-tool collaboration. I think you really hit it on the head. It's a realization that it's not just going to be one CAD program that gets you over the finish line, because these things get so complex and there are so many different tasks. There's the mechanical, there's the firmware,
you're absolutely right.
Yeah, there's manufacturing.
And there's too much for one person to do it all. Don't get me wrong, there are people out there that are one-man shows. Kudos to them. But when you think about all the expertise that's required, it's too much for one individual to be able to be an expert at every one of those little things, because you're not doing it every day. And that's what I liked about working at a service bureau or for a small engineering firm that sold its services, is because you were working on a diverse set of projects that cover a spectrum, and you're having to push the envelope a lot of times to be faster and better. And so you've got to learn, find ways how you can carve out time in the schedule, how you can shrink the schedule. And you're not going to do that doing things manually, because you're a human. You can only work for so long. You can only go without sleep for so long. Believe me, I know, and I try not to do that. And but it's a challenge, and it's a challenge of how can I be faster and better, and have the quality be right there, and not have to work more than 10 hours a day.
Sure.
You know what I mean?
Yeah.
So and service bureaus, the really good ones, their team members are producing, and that's what they're doing. They're taking advantage of the automation in their tools, whether it be any of the EDA tools that are out there. Because believe me, the service bureaus have to be able to use or have team members that use multiple EDA tools in order for them to be successful and to thrive in business.
Oh, absolutely. Absolutely. In fact, I know that some service bureaus they win business based on that. Do you use this tool? Yes, we're experts in it. Well, then great. You're going to get the job. We can't find anybody that's experts in this.
No, you're absolutely right. You're absolutely right. And being multifaceted in multiple tools is a good thing. It's always good if you have the opportunity to learn another tool. But in the end, people are going to work with whatever tool they get hired into, and they'll assimilate to that tool. And my recommendation to them is just learn to master that tool any way you can, and take advantage of the horsepower within that tool to be successful. And that may be a mix of automation and manual approach, but anywhere you can automate something, try to automate it.
Yeah. You brought up auto routing, and I will admit I shy away from auto routing.
No, it's typical.
Yeah, it's typical. I'll admit that. I'm wondering though, since you seem to have your view is more welcoming of auto routing. What do you see as more appropriate to auto route versus something else? Like,
so when you think about big buses, or when you think of like RF designs, for example, you got a lot of shapes. If anything, you're going to use like maybe reuse, where you created a shape and you're going to reuse that shape. And so
that's exactly what we do on RF.
RF, when you're doing RF, the chances of auto routing are not slim to none. When I talk about utilizing horsepower, you as a designer have to understand when to apply that power that you have, and when you have to, or the horsepower in your tool, or when you're going to have to do things manually. But you look for ways and look for opportunities. How can I make it so I can do it faster? And it comes from years of lessons learned, and you also have to be willing to say, here's my comfort zone, and I'm going to step outside this comfort zone and be willing to try something different, or be willing to try this feature that's in the tool that we're paying hundreds of thousands of dollars for, and it's in this tool, but I never use it. Why not? Well, why don't you try it? And if it doesn't work, why didn't it work? I guarantee you, if you talk to the FAEs of your tool, they'll say, yeah, we have customers using it all the time. But I'll be the first to tell you that not every design can be auto-routed. You just have to choose and control your auto-router and when you can use it. And if you could save a day, 2 days, or a week and cut that off your design schedule, wouldn't you want to do that? Because I guarantee you your competitor is going to do that. And when you think of service bureaus, speed and quality is everything.
Yeah, absolutely. Absolutely. Yeah. And I almost see it as like, if you can plan smartly for auto routing, and you can set up that automation with certain portions of the design, it's probably going to work. It's probably going to be hard to break it. One example that comes to mind immediately is like I2C. I2C buses are kind of hard to break. So maybe that's a candidate for auto routing, or a bunch of GPIOs. Whereas I've never met anybody that would auto route like a DDR4 bus.
So I would tell you, the other day I was talking to someone and they're like, you know what, if you can't route, DDR, if you can't route it, within like 30 minutes to an hour, you're not using your tools, whichever tool you're using, you're wasting time. There's times that's time that can be spent downstream, and you should be able to do it faster than years past. You have to be willing to adapt and change, and it's just part of the evolution. I mean, think of the designers that were there before me and before you, and where we are now. Look how we're evolving, and the tools are evolving so rapidly. And it's behoove us to take advantage of the power in the tool to be better. Because I guarantee you at some point, and I just, I did an article with iConnect 007 and regarding AI and the future of PCB design and what is the approach and what do I think? What is my opinion? In my opinion, anywhere between 10, 15, maybe 20 years, who knows, some company or somebody is going to figure out how to have a computer design a board. And I tell you, when you think about the automation, when you're designing your constraints in your design, isn't that kind of what you're doing? You're putting your constraints in so that way you don't have to think about when you interactively route a trace, the computer is already mining the rules that you put in there. So when, I had this epiphany the other day when I finished the design and we were, talking with our customer and, we did the demo worked. It was amazing. It worked the first time out of the chute. And it was no surprise to us, but it's always good and rewarding when we hear from the customer and instantly. And I just thought, we did that really fast. And the customer was like, it's amazing how fast you guys did this. And then I started thinking, well, what if we had a machine to do it? Not me, but a machine. What if somebody had some algorithms or something and programmed a machine that took like lessons learned from hundreds of boards or thousands of boards and said, this is what we figured out when you route a power bus or when you're routing, DDR4 or when you're routing, Ethernet or whatever, this is what you need to do. And then all of a sudden, you think about how you can do it from a system architectural level, and then you can work your way down. Now, don't get me wrong. I'm not saying that a designer can be replaced, but at some point, 10, 20 years from now, I can see the evolution following, because look where we're progressing with AI right now and how far it's come. So somewhere, some company is doing this or is down this path.
Well, I can tell you, I know and have talked to the founders of one particular company that is doing this at the schematic level, not at the physical level yet, but definitely at the schematic level. And their tool does interface with Altium designs. Yes, you're right. It is a trend that is happening. And I think it's funny because sometimes you bring this up and then I think designers sometimes freak out and think, oh, there'll never be PCB designers in the future. This is, a dying art or whatever complaints they want to say. I don't think so at all. I think if you go back to the 1900s and you told people in 1900 that, in the future, only 0.2% or whatever percentage of people will be working on farms, when at the time, 30% of people worked on farms or something like that, some huge percentage. They'd say, well, what are people going to do for jobs? How are people going to, have their livelihoods and all of this? And it's not that the automation eliminates you, it's that it changes your role and refines it.
No, you're absolutely right. So what's happening is we are seeing a hybrid approach of the designer nowadays. Nowadays, the double E coming out of school is now the future designer. Why? Because think about what a company is willing to pay for. So this day and age, a company doesn't want to pay someone a certain amount of money so that way he has peaks and valleys where he's busy for 3 months, 4 months, and all of a sudden he goes into a valley where he's not really busy. He's waiting for the next design cycle to come. Then he's busy again. They want a double E because when he's designed the board, he goes into the next phase. So his return on investment to the company stays at a maximum output. So he's doing from design, then he goes into the firmware or whatever aspect. So when you think of today's designers that are the future designers of tomorrow, the young designers today, they're the hybrid. They're a double E with a double E background that are designing boards. And when you think about how complex our designs are getting, it's just it's by nature, it's evolving that way. Designers are having to become knowledgeable of the double E background, whereas the double E's are having to get the designer background. So you're getting like a hybrid approach and a blend of the two. And that's the next generation of designers. And then when you think of really downstream, like we talked about AI, the designer's not going away. The designer will just evolve. Somebody's got to control the system. Somebody's got to control how things are done. The design engineer will evolve.
Yeah, absolutely. And I know that Altium is trying to be at the cutting edge of that and enable that type of collaboration and access to those tools to help designers evolve. Just like
it would be behoove them to not chase after that ring, that golden ring. I would tell you, in my vision, I see that, at least how I seen, when I first started to where we are now. Whichever EDA company really embraces that and goes after it, they'll be the game changer. They'll be the game changer for sure. And like you said, you already know somebody that's just doing the schematic. I can tell you, in the recent project I worked on, when we talked about the integration from our system architect into our schematic and into our layout, it was very seamless in how their approach was. And it was as if we designed it at the system architect level by the time we got to layout. And it was extremely effective. And we were able to do it rather quickly versus, years past.
Sure, absolutely. Well, I think for now we're going to have to leave it there because we're running out of time. But I'm sure you and I could talk for another hour if we really wanted to.
Easy.
Yeah, absolutely.
Especially with me.
Well, thank you.
It's my pleasure. It's my pleasure. And thank you for having me. It's always an honor to come on the podcast. I think you guys are doing an amazing job. Keep it up. If you guys, check out PCEA.org, check us out. My Evolve, be a part of the collective. It's, you'll see us, with our recent acquisition of UP Media, you'll see us a lot more than years past because, we're only 2 years old, but it's amazing how fast we're growing. You figure our 17 chapters and all the amount of our affiliations that we have. It's truly amazing how things are evolving for PCA. So definitely be a part of the collective so we can help share that knowledge and pass it on to the new generation.
Absolutely, yeah. We'll have a link to the show notes to the PCEA website, so everyone can learn about this important organization. Stephen, thank you so much for being with us, and to all of our listeners, check out everything in the show notes. Go register for Altium Live if you haven't already. It's going to be great this year. It's back in person in San Diego, and I'm excited to be there. Stephen, I hope you're going to be there.
Yep. Yeah, that's the plan. Last time we talked to Judy. So it'd be good. I'm excited. I'm always excited. A lot of great individuals out there. Some really great content at Altium Live. It's a hell of a show. So definitely want to be there.
Absolutely. All right, everybody. Thank you again for tuning in. Thank you, Stephen. And if you're out there listening, don't stop learning and stay on track.